Alright, these are the notes for lesson 19. So in lesson 19 there's several things that we're going to go over. The first one is talking about nonlinear equations. So if it isn't nonlinear, it means it's linear. So something other than a line. So there are some things you should have already learned about or seen, at least seen, like a circle. You should know that the equation of a circle looks like x squared plus y squared equals, say, 25. In that case, the center is 0, 0, and the radius is 5. A parabola, these are just the basic ones. A parabola might look like y equals x squared. Oh, wait a minute, let's see. So we know what a circle looks like. Well, it has a radius of 5. So that would go through the point 50 there and the point 05 there, right? If it was a parabola, they look like this. It looks sort of like a U. Or a hyperbola. A hyperbola has an equation that's similar to like x squared minus y squared equals 25. It can look quite different with a hyperbola, though. Like xy equals -9 is also a hyperbola. So this hyperbola here would look like this. See, it's almost like a circle, but it has a minus here instead of a plus. So it's still going to go through the points like 5, 0, and -5, 0, just like this circle does. But it's going to look like this instead. It's like as if, and this is a really rough sketch, but it's like as if you just take this circle, and because it's a minus instead of a plus, we're going to flip this part out and flip that part out. But knowing generally that that's just what a circle looks like, a parabola looks like that, and a hyperbola basically looks like two of those, right? Then it helps you when you're getting ready for some of these problems. It says if you graph a circle line, how many possible points of an intersection could there be? Well, there could be 2 if the line goes through the circle, right? There could be 1 if the line was tangent to the circle. There could be none, or 0, if the line didn't touch the circle. So you have 3 possibilities. So thinking the same thing, if you had a line, it could, with parabola, it could hit the parabola twice. It could hit the parabola just once, say at that point. Or it could be down here and never hit the parabola. A hyperbola and a line. So if you have a hyperbola and you draw a line, you could draw a line this way and hit it twice. You could draw a line maybe straight up and down and just hit one of these once. Or you could have a line that's like right here, and it doesn't go through either one of them. But what about a hyperbola, this, and a circle? So what if it was a circle and it had a hyperbola like that? That's 1, 2, 3, 4 points. Or maybe it's a circle and this one's here, but this one's over here, so it's 2 points. Or maybe it's 2 points like that. Or maybe it's just 1 point, or maybe it's no points. Okay, so you just have to think about different possibilities. Because if you're thinking about how many different answers you're going to have, or could have, it will help you not miss half the problem. So let's do example 19.2 in your textbook. So 19.2, it gives you these 2 equations. The first equation is x squared plus y squared equals 9. They tell you in the book that's a circle. You should become familiar with that. They tell you that the second one, which is 2x squared minus y squared equals -6, that's a hyperbola. Now, I don't know exactly what it looks like just by looking at this, but I know that it's a circle and a hyperbola. It might have as many as 4 points of intersection. So remember, anytime we're solving, we're always solving for these points of intersection. Now, I'll tell you that I can graph these because I know that this circle has a center of 0, 0 and a radius of 3. So I know it's going to go through these points. So I could do a rough sketch. I know that that's a hyperbola, and just because, I've been doing it for a while, I could easily find the points of intersection there. But I'm going to show it to you algebraically because you don't know how to do everything graphically yet. So algebraically is the way we're going to handle this. We're going to take these two and we're going to solve them. Since these are both y squares, I can add these two equations together, and I get 3x squared equals 3. So x squared equals 1. If I take the square root of both sides, I get positive and negative 1. That's important. Negative 1 times negative 1 is also a positive 1. For each one of those, for x equals 1 and x equals negative 1, I need to find my y value. And I can plug it into either one of these. I'll just pick the first one because it's simpler. So 1 squared plus y squared equals 9. So that means y squared equals 8. So if I take the square root of that, I get 2 times the square root of 2, but I get positive and negative. That means for this one value of x, I get 2 values of y. That means I have 2 answers, 1 and 2 times the square root of 2, and 1 and negative 2 times the square root of 2. Now, when x is equal to negative 1, I'll just plug it in the same equation. And I can use either one, it doesn't matter. And you can see I'm going to solve and end up with exactly the same thing. But this time my x is a negative 1. So I have negative 1 and 2 times the square root of 2. Negative 1 and negative 2 times the square root of 2. So I have 4 answers. Now, 1 and 2 times the square root of 2 is probably going to hit about right there. Negative 1, 2 times the square root of 2 is going to hit about right there. I mean, that's telling me that this is probably like this. The others are going to hit about right here. And that's what it looks like graphically. Just a real rough sketch. I mean, that's not a great sketch, but it's a rough one. Okay. Then on the back, we're going to look at 19.4. And it has this equation, or this expression. It's not an equation. Doesn't have an equal mark. Now, in order to factor this, the first thing we're going to do is we're going to go back a step. If we have x to the 2n plus 2, then the step before it got to that point probably looked like x to the 2n times x to the second, because then those are like bases and we add their exponents. So we're going to undo that on each of these. Then we can more easily see what our common factors are. I have a 3 and a 12, so a 3. I have x to a 2n, x to a 3n, so x to a 2n. I have x squared and x cubed, so x squared. So what did I have left? Here, I factored everything out. Here, I'd have a 4, an x to a 1n, and an x to the first. Because when I multiply, this would be x to the 3n, and this would be x cubed. Now, I'm not going to leave my answer like that. That's just the form we worked it in. I'm going to move it back and make it look more like this. So that means I'm going to add these exponents. Add n plus 1. So this is my answer. Okay, moving on to 19.5. In this example, they're trying to show you another form of the difference of two squares. So we have x to the a power plus y to the b power. So I know by the exponent rules that this can be written as x to the a squared, because that would be 2a, and y to the b squared. That's using the rule of exponents. Now, this is the difference of two things being squared. So using the difference of two squares theorem, I know that this will factor then as each of the terms plus and then each of them minus. Now this is over this one right here, which happens to be that one right there. So those are going to cancel, and it'll simplify to this. Okay, the next one, and you probably never got to this last year or whatever, but the sum and the difference of two cubes. So you need to memorize these formulas. Now I want to show you a similarity. You're going to see I'm writing it sort of funny here. Okay, before we get into everything about the second one, when it's plus, this first one is plus. When it's minus, the first one is minus. Now the three terms, a squared, ab, and b squared, are the same in both. But when it's plus, this one's minus. When it's minus, this one is plus. So this follows that, and this will always be different. The last ones are always plus. Okay, so example 19.7 gives you this problem, and it tells you to factor it. So the first thing you need to do is you need to figure out, what are you cubing? Like, it says a cubed minus b cubed, and this is a minus, so we'll be using that one. So it says, which form do you use? I'll put the difference of cubes. That's the form that we're going to use, okay, this one. But I got to figure out what is being cubed. Well, xy is being cubed, and then p is being cubed. Now the reason I have to figure that out is because I don't have an a and a b. My a has become xy, and my b is the p. So I'm going to take these and sub it in for a and b in that formula. So I'm going to have xy minus p. Wait a minute, let me get started here. You're going to write x cubed, y cubed minus p cubed equals. And then you're going to put this in the formula. Now I'm going to do xy squared. That means I'm going to have x squared, y squared, plus a times b. That's this times this. So p xy plus b squared. That's this p, so p squared. And that's finished. You need to make sure you include this with it, okay? See you later.